yesterday with those new vocabulary words, chords and arcs. So let's take a look here. We're going to still refer back to central angles, and then we're going to look and kind of incorporate that with chords and arcs a little bit more. So just a quick review that congruent central angles have congruent arcs. So if I were to have my circle here, okay, remember that a central angle, excuse me, is going to have the radius as the center, okay, or excuse me, the radius as the sides, all right. And so remember that this angle is equal to that arc. Okay. If I were to have another central angle, okay, here and here, and this angle is the same as the other angle, then this arc is going to be equal to the other arc. That just makes sense, right? Because central angles are equal to the arc length. If we have two angles that are equal, then the two arcs are going to be equal there. Okay, so just quick review. Here, let's put some letters to this. Let's say that this is A, this is B, this is C, this is D, and this is E. Okay, so basically, we're going to have the measure of angle ABC is going to be congruent to the measure of angle DBE. And then we also have the measure of arc AC is going to be congruent to the arc of DE. Okay, so that's just basically we're going to remember central angles are equal to their intersected arc. So the arc in between the two radius that makes up that angle. And then we have congruent central angles have congruent chords. So here we go. If we have a circle here and let's put our center, okay, and we have a central angle. Let's say our central angle is this angle right here. If I were to make this chord, the segment that intersects two sides of the triangle, I mean, two, I want to say sides, the outer edge or the edge, it intersects the circle. Yeah. So it's just a segment that intersects a circle. So if we put some letters here, let's say that this is A, this is going to be circle B again, and this is C. And then I have another angle that is going to be congruent to that angle. Then the chords, this distance here is going to be the same. So let's say that this is D and this is E. And then, so basically, AC is going to be congruent to DE. And that's a line segment, not an arc. Okay, so make sure you note that. And then congruent chords have congruent arcs. So if I have my circle here again, and then I'm going to have my align segment from here, let's say to here, and then I have another one from here to here. So let's say that this is A, let's call it, yeah, we'll call this A, this is B, this is C, and this is D. If AB is equal to CD, so I know these are true, then I know that this arc is going to be congruent to this arc, okay? So basically, the measure of arc AB is going to be congruent to the measure of arc CD. And that would be our equation there. Also noting that the line segments AB arc is congruent to line segment CD. All right. And then the last one, chords equidistant. So the same distance from the center are congruent. So again, if I have my circle and I'm going to have two chords here. So I'm going to draw them very similar to what we just now had. Okay. And so this is going to be A, B, and this is C, D. And here's my center. If the chord is the same distance, so if this distance is going to be, if those two distances are the same, then AB is congruent to CD. So I need where this intersects at. So I'm going to call this X and this one Y. Okay. And this center will be Z. So basically, if XZ is congruent to ZY or YZ, then we talked about if then statements, right? Then line segment or chord AB is going to be congruent to chord CD. So all of those things are going to help us in just a second when we look at these and try to find some different values in our circles. So let's look here. We have, we're trying to find the value of X there. So what you'll note is that these two chords, so this chord here and this chord here, are the same distance. So we know that this length is going to be equal to the other length. So let's just name this AB, and this is going to be CD. So we know, so that way we can kind of refer back to it. So we know that AB is going to be equal to CD because they're the same distance from the center of the circle. So if AB is equal to CD, okay, and I know AB is X and CD is 2 times 6.3. So 6.3 is referring to this part. These are equal parts here. So it's 2 times that. So 6 is going to be equal to 12.6 because those two chords are congruent or they're the same, and I know that one of them is 12.6, so the other one has to be 12.6. All right, so we're trying to find X here. We have a chord that is 10, and then it's 4.2 from the center, and we have X, that's the radius. So the radius is the distance from the center to any edge of the circle. All right, so we are going to if that's X, then this is X right here as well. It goes from the center to the edge. Well, that's the case. This is a right triangle. This cuts it. This makes a perpendicular bisector, and it cuts it in equal parts. Okay. And so, therefore, I'm going to have this piece is 5, this piece is 4.2, and the radius is X. So I have 5 squared plus 4.2 squared plus, excuse me, equals X squared. So Pythagorean theorem, A squared plus B squared equals C squared. All right. So I'm going to have 25 plus 17.64 is equal to X squared. Then I'll add those two together, and that's going to make 42.64 is equal to X squared. And remember, the last step to get X by itself here is to take the square root. And I get 6.53 equals X. So remember that has to be the that has to be the hypotenuse because it is across from the right angle, and it is longer than any of the other two sides. So we, as a little check there. Okay, and so now this time I'm going to find the value of X, and it's going to be the length of the chord here. So I know that this distance is 8 and this distance is 15, and these two are the same. So basically half of X. So what I'm going to do is I'm just going to find this distance from here to here, and then I'm going to multiply it by 2 to find the whole value of X. All right. So this is going to be one leg. That's going to be A. Here's B, and here's C across from the right angle. So therefore, I'm going to have A squared plus 8 squared is equal to 15 squared. So A squared plus 64 is equal to 225. And then I'm going to subtract 64 from each side, and I'm going to get A squared is equal to 161, and then I'll take the square root of 161 here. And so A is going to be equal to 12.69. And then I will basically double that. So I'm going to take that and multiply it by 2 to get the whole value of X. So X is going to be equal to 25.38. So I had to multiply it by 2 because my X was, when I found A, that was just half of the length of X. I needed to find the full length there. All right. So this is just using chords and arcs and using those theorems that we've talked about to be able to find different values here with chords and the distance from that to the radius, or define the radius, and lots of different things there. So just keep in mind those theorems and keep those handy. It's a really good idea to kind of sort of start letting this start sinking in and become more aware of what's a central angle, what's an inscribed angle, what's a chord, and that kind of sort of thing. What's a radius, and being able to identify those types of things for the circle. So now it's either your turn to try and practice with quizzes or skip right ahead to your skill check.